these are the solutions to the 3D Pythagoras and trigonometry questions on pastpaperpenguin.com. For this first question, it's a 3D Pythagoras question, and I'm going to show you two ways to do it. The first way I'm going to show you is a slightly longer way, but it's the way that makes more sense to more people. Then the second way I'm going to show you is a bit of a shortcut, which you can use in certain situations, but not always. So watch both ways, because the second way is what I'm going to be using for quite a few of the questions in future. So first of all, we're asked to find the length AG, so I'm going to draw that in to begin with. And then I'm going to find a right angle triangle that includes that line. And the right angle triangle that I'm going to use is that one there, with the right angle being there. This is the side that I'm trying to find. Let's maybe label it X. Now, to be able to find that, it's the hypotenuse. I need the two shorter sides. I know that this one here is 3. I don't know what this one is. So we need to work that one out. So I'm going to use a different triangle to work that one out. And the triangle I'm going to use is this one here. I'm going to label the side there Y. I'm also going to draw that triangle from above. Okay, so if I'm looking down at that triangle from above, this is what it looks like. This side is Y, this side is 4, this side is 6. I'm now going to use Pythagoras on this triangle to find out the length Y. So Y squared equals 4 squared plus 6 squared. That's 16 plus 36. Add those two things up and we get 52. So Y is equal to the square root of 52. Now we're going to use that in the blue triangle. So this is the blue triangle. And the sides of the blue triangle are 3 here, X here, and down here that was Y. We found out that that was the square root of 52. So now I'm going to do Pythagoras again. So the hypotenuse, x squared, equals 3 squared plus the square root of 52 all squared. 3 squared is 9. The square root of 52 squared is, you guessed it, 52. And those two things added together is 61. Now the square root of that, so x is equal to the square root of 61. All we need to do now is to check that that doesn't simplify, you know, that there's not a square number that's a factor of 61. There isn't, so that's going to be my final answer. Now I'm just going to show you the quick way here. Now when we have these 3 sides and we're looking for the hypotenuse that goes from one corner of all of those 3 sides to the other, we can do it all pretty much, well, we can do it all in one step. We can use 3D Pythagoras, and this is how that works. I'm going to do x squared equals 6 squared, add 4 squared, add 3 squared. And then let's work those out. So 36, add 16, add 9. So that, if you add them all up, you'll see that it's 61, and then square root. Okay, so see how much quicker that was. The only thing I would say is that works really well when you have the hypotenuse, when you're missing a hypotenuse. It starts to become more complicated to use that if you've got one of those shorter sides missing. That's where mistakes start to happen. So I'd maybe recommend doing it in that kind of situation, but maybe not in others. And if you're not 100% sure whether you could use it, stick to the slightly longer method. Okay, it's still is quick enough to merit the 3 marks that you get here. In this next question, we're asked to find the angle between the line PC and the base ABCD in this triangular prism. Let's first of all draw the line PC that they're talking about. And when they're asking us to find the angle between the line and the base, what that actually means is we want the angle between this line and the line that would be directly underneath this one that runs along the base. Now you can see that A is directly underneath P, so our line is going to start from there, and then the line runs all along the bottom of the shape to see where that line starts. That's the triangle that we're going to be using. Let me draw it over here. So here we have PAC. This is the angle that we're trying to find, the angle between the line PC and the base. And so far we only have one of the lengths of that triangle. We have this one here is 4 centimeters. So to be able to find that angle, we need at least 2 of the lengths, so we need one more. If we've got one more length, then we can use SOHCAHTOA. So I need either this hypotenuse here or this base here. Either is fine. It's going to be slightly quicker for us to find the bottom side using this triangle here. Let me draw out what that red triangle looks like from above. Okay, it has a right angle here. Yeah, that's a right angle if you look down straight from above. This side here is 7, this side here is 5, and this side here is that bottom side there. Let's call it Y. Okay. So to find that side there, let's use a bit of Pythagoras. Y squared equals 5 squared plus 7 squared. So 25 plus 49. So 74. So that means y is equal to the square root of 74. Let's just leave it like that for now. It's not something that simplifies anyway. So now I'm going to replace that there with the square root of 74. Let's give ourselves a little bit more space. Okay. So now we're going to use SOHCAHTOA. Which trig ratio are we going to need? Have a think about it. And the correct answer is we're going to be using tan. Okay, because we've got the opposite side and the adjacent side. So TOA, so we have tan x is equal to the opposite 4 divided by the adjacent root 74. So x equals arctan of that. Plonk that into our calculator, make sure it's in the right mode. I get 24.9 degrees. Remember, we want answers to 1 decimal place. In this next question here, we're told about a cuboid which measures 24 by 12 by 8. I think whenever you're given a shape and are not actually shown the shape, it's often quite a useful thing to actually sketch it. So I'm going to make a quick sketch of the cuboid. Doesn't need to be to scale. It's just going to give me a rough idea of what I'm trying to find. Whoops. I'm sure you can do a much better job than this, but that's good enough for me. So now I'm going to draw the diagonal of that cuboid. Okay, oops, what I should have done first is to maybe label the lengths. Doesn't matter what's what really, it's not to scale. So this one can be 24, this one can be 12, this one can be 8, and I'm trying to find the length of that line. There's 2 ways to do this one, like with the very first one we did. You could either find this length here using that triangle and then use this triangle here to find that one, but what I'm going to do is use that shortcut of using a bit of 3D trigonometry. I'm going to call this one x, and I'm going to do x squared equals 24 squared plus 12 squared plus 8 squared. So x is equal to the square root of all of those things. Don't even need to work out what they are. Let's put that all into our calculator, save ourselves a little bit of time. We get 28. Okay, so that was actually a nice quick question. It's really important to notice, by the way, this is a common mistake, that when you're square rooting separate terms like this that are added together, you cannot square root them individually. So this is not the same as 24 add 12 add 8. That doesn't give us 28. It's a common mistake there that students make. Watch out for it. Here we're given a rectangular box and there's a stick inside the box resting against A and G. We want the angle between the stick and the base of the box. Let's draw in what we know to begin with. So here's our stick. So again, the angle between the stick and the base, we want the line directly underneath that runs along the base of the box. So directly underneath G is C. Let's draw that line in there. This is the triangle we're going to be using. This is the angle that we want to find here. Let's label it X. I'm going to draw a quick sketch of it over here as well. And we've got one of those lengths. That length there is 14.5. So let's draw that in. And we need another length on this triangle to be able to find out what that angle is. Let's call this length here Y. Put it on there as well. And I'm going to use this separate triangle on the base here to find out what Y is. So let's draw that one as well. Okay, so we have a right angle here, and this side here is 9, this side here is 18.6, and this is Y that we're trying to find. So for this one we're going to use Pythagoras again. Y squared equals 9 squared plus 18.6 squared. So Y is equal to the square root of both of those things. No need to actually work them out. Let's put that into our calculator. I didn't get a nice answer for this one, okay? I got 20.663, etc. Now what I'm going to do with that is either keep quite a few extra decimal places or I'm going to store it, okay? So to store it, on my calculator I'm going to press STO, and then one of the buttons above which has A, B, C, D, E, F. Okay, and then it says the answer's been stored into A, and I'm going to use that again in a moment. Okay, so now I'm going to be using this blue triangle over here. I have the opposite and the adjacent side, so using SOHCAHTOA, that tells me I want tan. Opposite and adjacent, so tan x equals the opposite 14.5 divided by the adjacent 20.663, or even better, the stored answer from your calculator. And then I'm going to do arctan of that thing there. So arctan 14.5 over, and if you're using your calculator memory, I'm pressing shift and then recall and then A, and I get 35.058, which to one decimal place is 35.1 degrees. If you'd use 20.663, you'll get the same thing. Okay, so as long as you use a few more decimal places, then you should be fine. By contrast though, if you'd rounded this and written 20.7, you would end up with 35.0 here, which would be wrong. Okay, don't round anything midway through your answer. Either store it or use a few extra decimal places and only round your final answer. So in part B we're told that AM equals 30. AM is the length of the whole stick. Show that GM equals 4.8, correct to one decimal place. Okay, so we're going to use our picture to find AG. Maybe to do that, let's get rid of some of those extra lines on the picture and make a copy. Okay, so we could use the information that we've used above and maybe do soccer tower. I think it might just be easier to use 3D Pythagoras just to find the length of AG, because then it avoids us getting any kind of rounding errors from anything up there. So to find the length of this thing here, let's call it x. I'm going to do x squared equals 18.6 squared, add 9 squared, add 14.5 squared. So x is equal to the square root of all of that. So let's type all of that in. So 18.6 squared plus 9 squared plus 14.5 squared. And I get 25.24. I'll put 243 for now. Okay. And then we're asked to show that GM equals 4.8 correct to one decimal place. Okay, so then I'm going to do, to find GM, I'm going to do AM, the length of the whole stick, take away that length there. So I'm going to do 30 subtract 25.243, that whole thing that I just got. And when I do that, I get 4.757. And it's important at this point to write a few extra decimal places. Because it tells us to show it correct to one decimal place, it kind of really wants, the examiner wants us to convince them that we know how to round. Okay, so at this point, because this is a 5, this one rounds up. So to one decimal place, it's 4.8. So when it says something like that, correct to one decimal place, it's always worth just showing a few extra decimal places and then justifying it by showing how you've rounded. So there we go, that's that one done. This time we're given a pyramid and we want the angle that VC makes with the base ABCD. So let's just show that line. First of all, there's VC. And here's the right angle triangle that we're going to be using. So this is the line directly underneath VC. Okay, M is directly underneath V. Okay, so this is the line that's directly underneath that. So the angle that we're trying to find is this one here. Let's label that as X. Okay, I'm going to draw that triangle over here, as always. Here's our right angle. This is C here, this is M, this is V. And all we know so far is that that is 14. So we need one more length on this triangle here. I guess this bottom one is going to be the easiest one to find. So let's try and find what this length is here. What I'm going to do to find this one is, actually I'm going to do the line all the way across here. I'm going to find the length of this red line and then I'm going to half it to find C to M. So here's the triangle I'm using. Again, I'm going to do a little sketch of it over here. Here's my right angle. That's that one there. When I look down from above, that is a right angle. That there is 12. Sorry, that there is 10. This one here is 12. And let's call this whole length here Y. And use a bit of Pythagoras. Y squared equals 10 squared plus 12 squared. So Y is equal to the square root of those two things. So the square root of 244 I think it's maybe safer to write it like that. You could also write it as 2 root 61. If you wrote it on your calculator, that's fine. Okay, I'll just show you why you need to be a little bit careful with that in a moment. Actually, we don't need to be a bit careful with that. The thing I was going to say is when we square it later, where it can go wrong is if you forget to put brackets around it when you're squaring it. Actually, I forgot something now. I forgot that we're going to be dividing this by 2. Okay, because that's the whole of that red line there. We said that this thing here, we were going to do 2 root 61 divided by 2, which is root 61, and that's that one there. Okay, so now let's use a bit of SOHCAHTOA in this triangle. So in this triangle, this is the hypotenuse, this one here is the adjacent, so we're going to be using K. So cos x equals adjacent root 61 over hypotenuse 14. So x equals arc cos root 61 over 14. And put that into our calculator. And I get 56.1 to 1 decimal place. Another cuboid here, and we're told that this is 20, this is 5.5, and we're asked to find the angle between the line AG and the base of the cuboid. Let's maybe already draw in that line AG. Once again, we're going to draw the line that would be directly underneath that one running along the base. So that's the triangle that we're going to be using. That's the right angle there. What you will notice though is we don't have this length here, whereas previously we did have it. Okay, so even if we find this red line here, we still need one more side, and there's another bit of information in the question that we haven't used, and that's the fact that the volume of this cuboid is 495 centimetre cubed. So let's use that to work out the height there. So let's label that H, and for the volume of a cuboid it's just length times width times height. That's equal to 495. So 20 times 5.5 is 110. So 110 times the height is 495. So then for the height we're going to do 495 divided by 110, which is 4.5. So we can already replace that there with 4.5 centimetres. Now let's redraw our triangle. And we have that this length here is 4.5, and we're trying to find the angle between AG and the base, so that is that angle there. So we still need one more length on this triangle. Let's once again find this bottom side here. To do that, I'm going to use a different triangle. I'm going to use this blue triangle along the base. Let's call that length there Y. Let's also draw that blue triangle again. There's a right angle. This is 5.5. This is 20. This is Y. Let's use Pythagoras. Y squared equals 20 squared plus 5.5 squared. So Y is the square root of that. Put that into our calculator. Again, this one I get a little bit of a horrible answer. What I'm maybe going to do with this one instead is I've worked out 20 squared and 5.5 squared, and that gives me 430.25. I'm just going to write that under the square root and use that instead. Okay. You could also get whatever answer you get for that and store that, or use a few extra decimal places. Either is fine. Okay. And whatever you use, I'm now going to put it back into this triangle up here. Okay, so let's use SOHCAHTOA. And I have the opposite and I have the adjacent side, so that means I'm going to use tan. So tan x equals the opposite, 4.5, divided by the adjacent, whatever you wrote for this. I wrote the square root of 430.25. So x equals arctan of that. And whatever that is to one decimal place. I get 12.2 degrees. In this question we have another pyramid, and again we're trying to find the angle that the line AV makes with the base. Let's draw in the line AV. Let's now draw the line directly underneath that. Directly underneath V is M. Let's connect that up to A, and this is the triangle that we're going to be using there. Let's make a sketch of it over here. So V at the top, A over here, M over here, and we know that this length here is 18.6, and the angle between that line and the base is this one. Let's label it X. So that's the angle we're trying to find. To work that one out, we need one more of these sides. The side we're going to be able to figure out is the one along the bottom here. Let me show you the triangle we're going to use for that. It's this one, with the right angle being along the base there. I'm going to make a sketch of that triangle as well. There's the right angle. This side here is 11. Now it looks like we don't know this side here. Let's read the question again. It does say it's a pyramid with a square base. If it's a square base, that means that this side is also 11 centimeters. So that's an important thing to notice. Let's label this side that we're trying to figure out here Y, and you'll notice I'm once again doing the whole length of this, and that then when we figured that out we'll divide it by 2 to work out just the length from A to M. So Y squared equals 11 squared plus 11 squared. So that's 121 add 121. So 242. So Y is equal to the square root of 242. And then we want to divide that by 2. Okay? So to find AM. Let's see if that gives us something nice on our calculator when we type it in. I'm just going to give that a go. Root 242 divided by 2 doesn't give me something particularly nice. Okay, it gives me 11 root 2 divided by 2. So let's use that then. Okay, so here I'm going to write 11 root 2 divided by 2. Maybe a slightly nicer way to write this is 5.5 root 2. It's a little bit easier because it's all on one line. So you could use that as well. Anyway, let's leave it as it is for now. So now here we go, we're going to use SOHCAHTOA again with this blue triangle. So SOHCAHTOA. And we have the adjacent side and the hypotenuse, so that's ka. So cos x equals the adjacent, that complicated thing, 11 root 2 divided by 2, all divided by 18.6. So I'm going to do x equals inverse cos of 11 root 2 over 2 over 18.6. To type that into my calculator, I'm pressing arccos first, then I'm pressing the fraction button, and then I'm pressing the fraction button again, now typing in 11 root 2 over 2 all over 18.6. And I get 65.3 degrees. If you don't like that 11 root 2 over 2, like I said, change it to 5.5 root 2, and then you avoid having that fraction within a fraction there. In this question we've got a cuboid, and we're trying to find the angle that the line BH makes with the face ADHE. So let's draw in the line BH, and we want the angle it makes with the face ADHE. Now ADHE is not the base this time. ADHE is this one here. Okay, so this time we need to think about if I was shining a light from this right hand side over here, what shadow would this line cast? Okay, well, this point here B, hold on a second, this point here B would be directly above that point there A. So I'm going to start from A and I'm going to go across to H where that line meets up. So that is the line directly underneath that one. Okay, so almost imagine like this is the top and this is the base this time. And let's draw in the rest of that triangle. That's probably the most difficult bit of this question. So if you can do that bit, the rest should hopefully be okay. The right angle is here. Okay, and now what we're going to do is we're going to redraw that blue triangle in 2 dimensions. There's the right angle. This one here we know is 15.1. The angle that BH makes with the face, that's that angle up here. So it's this angle that we're trying to find. Let's call it X. Let's put it on our little diagram as well. And then, as always, we're going to need one more of these lengths to be able to work out angle X. I think the easiest one to work out is going to be this one here. Let's call it Y. And that's by using a triangle over here. Okay, like this one down here. I'm going to redraw that triangle down here. There's our right angle. This is A, D and H. That's the right angle there. This side here, AD, is equal to 4.5. This side here, DH, is equal to 9.2. And that's our length Y. So Pythagoras, y squared equals 9.2 squared, add 4.5 squared. So y equals the square root of those two things. Now I think what I'm going to do is I'm going to work out 9.2 squared. That gives me 84.64. And 4.5 squared, that's 20.25. And I'm just going to add those up and keep it under the square root just so it's a little bit neater. So add them together and I get 104.89. The alternative to that is actually doing the square root, but if you do that you get 10.24158, and that's something that you either need to store or use lots and lots of decimal places on to make sure you don't get a rounding error. I prefer just to leave it like that. So that's the number I'm going to use here for y. Okay, so now we're on to our SOHCAHTOA step. And in this triangle, this is the hypotenuse here, this is the opposite, this is the adjacent. So we have the adjacent and the opposite, so it's TOA. So tan x equals the opposite, 15.1, divided by the adjacent, which is y, which is the square root of 104.89. So I'm going to do x equals inverse tan of all of that, and let's hope that gives us a reasonable answer. Yeah, I get 55.9 to 1 decimal place. We've seen a few questions like this already. We've got a pyramid, it has a square base, and we're trying to find the angle that EC makes with the base, ABCD. Let's draw the line along the base that's directly underneath EC. There it is. Let's complete that triangle. Let's draw in the right angle that we get, and then I'm going to make a quick sketch of that alongside. So here's our right angle, this is O, this is C, this is E, and we know that the height is 9, so we can label that as well, and we need one more side. Let's try and work out the bottom side. To do that, I'm going to draw a line across here, and once again I'm going to work out the whole length of that line, and then I'm going to half it to tell me what OC is. Here's that triangle, the red one that I just drew. I haven't really drawn it very well because both of these should be the same length, they're both 5. That there is a right angle, it's that one there. Let's call this side that we're trying to find y. And a bit of Pythagoras, y squared equals 5 squared plus 5 squared. So 25 plus 25. So y is equal to the square root of 50. If it's a calculator paper, you can type that into your calculator. If it's not, you can probably quite quickly figure out that that is root 2 times by root 25. So that is 5 root 2. Now that's the length of that whole line. We only want half of that, so we need to divide that by 2. And we can write it like that. It's another one where, if you prefer, for this working out step, you could also write it as 2.5 root 2 if you don't like having that fraction like that there. And sorry, it's not that length that we're trying to find, we're trying to find the angle that it makes with the base. The angle that it makes with the base is that there. So, SOHCAHTOA. In this triangle, we don't have the hypotenuse, we have the opposite and the adjacent, so we're using TOA. So let's write tan x equals opposite 9 over 5 root 2 over 2, or 2.5 root 2, or whatever you worked out for that one. So we're going to do arctan of all of that. So I'm pressing inverse tan, then the fraction button, then I'm putting 9, then going to the bottom of the fraction, and I'm pressing the fraction button again. 5 root 2 divided by 2. I got 68.6 degrees. This question gives us a triangular prism. Part A asks us to find AC, which is that line there. Again, this is one where you could do it in a few steps by finding out what that line is along the bottom there using this triangle here. But we can also do it using a bit of 3D Pythagoras. I'm going to do it that way. If you don't like doing it that way, have a look at the very first question in this series and it will show you an alternative way to do it. So let's maybe call AC x instead, and x squared is equal to 12 squared plus 5 squared plus 4 squared. So x is equal to all of those things added up and square rooted. We could type that straight into our calculator. We could also work them out. What's that? 144, 25, 16, 100 and what is that? 185, I think. So square root of that. Let's write it to 3 significant figures. I get 13.6 centimeters. So that's our first part done. Let's start having a look at the second part. Calculate the angle between AC and the base ABPQ. Here's our line AC. The base ABPQ is the bottom of the shape, so we want the line that is directly underneath that one. Directly below C is P, so let's join that up to A. This is the triangle we're going to use. Here's the right angle. Let's make a quick sketch of that triangle all the way down here. And we found that the length of x was 13.6. I'm going to use the exact form though. I'm going to write square root of 185 because that 13.6 is rounded. This thing here is not. Okay, to be able to find the angle, well, first of all, the angle between that line and the base is this one here. Let's call it y. I need one more length on this triangle. I think I'm actually given one. Yeah, I'm given this thing here. CP is 4 centimeters. So I know that this thing here is 4. So we can straight away go to using SOHCAHTOA. I've got the opposite side and I've got the hypotenuse. So it's so sine y equals opposite 4 divided by the hypotenuse, root 185. So y is inverse sine of 4 over the square root of 185. Put that into our calculator. And I get 17.1 degrees. This question tells us that we have a cube and we're given the length of the diagonal. Let's write in the length of the diagonal, 8.5. Now in a cube we know that all of the sides, all of the edges, are the same. So we can maybe write the same letter for each of them, x for that one, x for that one, x for that one. And if we were finding that length there, we could use 3D Pythagoras to do that, like we've done in previous questions. So that would be 8.5 squared equals x squared, add x squared, add x squared. Let's simplify that. And let's also work out what 8.5 squared is equal to. 8.5 squared, I got 72.25. And x squared add x squared add x squared. Careful, common mistake when adding these things up. It's 3x squared. Careful, not x to the power of 6. That would be if we were multiplying them. So now all I need to do is solve this equation. Okay, x has been squared and then multiplied by 3. So what I'm going to do first is I'm going to divide by 3. 72.25 divided by 3 doesn't give me a very nice number. So actually what I'm going to do is just write 72.25 over 3 for now, so that I don't have to round anything. And then I'm going to square root. And we're square rooting the whole thing, top and bottom. So that's what I'm going to type into my calculator. Press the square root button, press the fraction button, 72.25 all over 3. And I get two things. I get 17 root 3 over 6. But if I press my SD button to turn it into a decimal, let's write that. It doesn't ask for the exact answer, so I'm going to do it to 3 significant figures, which is 4.91 centimetres. The second part of the question wants me to find the angle between AB and the base of the cube. So our line AB is this diagonal one here. And the base of the cube, okay, so directly below B is here. So this is the triangle that we're using. Our right angle is here. Let's make a copy of that triangle down here. This is the angle that we're trying to find. Let's call it y, since we've already used x. And we know that the hypotenuse is 8.5. And we've also already got what this side is on the right hand side over here. Okay, because that's x, and we worked that out up here. It's 4.91, except I don't really want to use that rounded answer, so I'm going to write this kind of horrible looking thing over here, 17 root 3 over 6. You could also use 4.91 as long as you've stored that value and you use a few more decimal places, just to make sure we don't get a rounding error. So, SOHCAHTOA. In this triangle we've got the opposite side and we've got the hypotenuse. So it's SOH. So let's use sine y equals opposite over hypotenuse 8.5. So y equals inverse sine of all of that. So I'm pressing inverse sine, then I'm pressing the fraction button, then I'm pressing the fraction button again. 17 root 3. Down to get to 6, and then down again, 8.5. Close the brackets, 35.3. If you got a slightly different answer, it's probably from a rounding error from using 4.91 instead of your unrounded answer. Here we've got another question with some sort of stick or rod inside a box, and it wants the length of rod which is outside the box. To find that, the easiest way is to find the length of rod inside the box, so let's do that. Let's find the length of A to G. Okay, to do that I'm just going to use a bit of 3D Pythagoras like we've done a few times already. Let's call the length x, so x squared equals 20 squared plus 18 squared plus 16 squared, so x is equal to the square root of all of that. You can work these things out individually, but there's no need. Type that into our calculator. I get 14 root 5. Now that's the length of AG, but we are told that the rod is 40 centimeters long. So from A to X is 40. This bit is what we just found. So to find the length which is outside the box, we're just going to subtract. So I'm going to do 40, take away what we just figured out. So gx equals 40, subtract that, doesn't tell us, it wants it in exact form. So we'll do it to 3 significant figures. I got 8.695, so to 3 significant figures, 8.70 centimetres. The second part wants the angle the rod makes with the base. Let's draw in the line which is directly below the rod, so directly below G is C. And the angle that that rod makes with the base is this one here, let's call it Y. And let's make a copy of that triangle that we're using, that triangle AGC. So we're trying to find angle Y. And let's fill in any lengths that we know. We just worked out what X is. That was 14√5. And we know one more of these sides. We know this one here. We know that GC is the same as EA, so that's 16. Now we can use SOHCAHTOA. We've got the hypotenuse. We've got the opposite, so we're using SOH. So sine Y equals opposite, 16 divided by hypotenuse, 14√5. So Y is equal to inverse sine of that. Put that in our calculator. I got 30.7 degrees. We've got a cuboid measuring 6 by 3 by 2. We want the sine of angle PAN. They've drawn the triangle for us. I'm going to go over it a little bit more clearly. Let's maybe label that angle X. Okay, and as always, let's make a quick sketch of that alongside. That's the right angle that we've got. We're trying to find X here, and let's show any sides that we've got. We know PN, that's the same as that one there, 2. So we know that that one there is 2. To be able to find that angle, we need one more side. So we need a different triangle for that. This is the triangle that we're going to use to find that bottom side there. There's the right angle. If you're looking down from above, it is a right angle, that one. Here's that red triangle that I just drew. There's the right angle there. Let's call this side Y. That's what Y is on the blue triangle. Here it is on the red triangle. This side here is 6. This side over here is 3. So let's first of all find what Y is equal to. Using a bit of Pythagoras. Y squared equals 6 squared plus 3 squared. That's 36. Add 9, so 45. So Y is equal to the square root of 45. We could do that in third form. That is square root 9 times square root 5. So 3√5. So now we know that this thing here is 3√5. Okay. So if we now look at SOHCAHTOA, you will notice that the sides that we have here are actually for tan, opposite and adjacent. To do sine of the angle, because notice it doesn't ask us for the angle, it wants the sine of the angle. To do the sine of the angle, we want to know what the hypotenuse is. Okay, so to do that, let's work out what this side is here. Let's call that side there Z. And Z squared equals 2 squared, add 3√5 squared. 2 squared is 4. 3√5 all squared is the same as root 45 squared, so that's 45. That's 49. So z equals the square root of that, which is 7. So that's quite a nice number there. So finally, now we can do the sine of that angle. Sine x equals opposite 2 over hypotenuse 7. So the sine of that angle is 2/7. Now that could definitely be a question that is on a non-calculator paper, because none of those square roots were difficult to find out, and we don't actually have to do inverse sine of 2/7. It just wants sine of that angle. So watch out for tricky questions like that. We've got another cuboid. We have a square base, and we're told that CG is 20 centimeters, but it's not written in, so let's write that in there. CG is 20 centimeters, and AG is 28. And we're asked to find the value of x. So we're going to do this like a 3D Pythagoras question. So if we were trying to find AG, well, AG squared, so 28 squared equals this side squared, add this side squared, add this side squared. So x squared, add x squared, add 20 squared. Let's work out what we can. So let's do 28 squared, that's 784. X squared add x squared, that's 2x squared. And 20 squared is 400. Let's now solve that equation by subtracting 400 from both sides. That gives me 384 equals 2x squared. Next we need to divide by 2. So 384 divided by 2 is 192. And then we're going to square root that for our answer. And that gives me 8 root 3. It doesn't ask for it in exact form. I think it would be okay for us to write 8 root 3. I'm going to write it to 3 significant figures though. I'm going to write 13.9 centimeters. This question is similar to ones we've already done, but there's a slightly little trickier bit to it. Okay, we're told AG is 24, there it is there, CG is 6, and AB equals 2BC. Okay, so if AB equals 2BC, that means if BC is equal to X, AB is equal to 2 times that, so 2X. So we want something like that, using a variable there, like Y or X or something, with this one being twice as long as that. And I think once you can do that, it becomes quite similar to other questions we've done. Because now we're again going to use 3D Pythagoras with all of these measurements. So 24 squared is equal to, careful, 2x in brackets squared plus x squared plus 6 squared. 24 squared is 576. 2x all squared is 4x squared. That's why the brackets were important. Plus x squared plus 36. Let's simplify the right hand side. 4x squared add x squared is 5x squared. And now let's start to solve that equation. So first we're going to subtract 36. So 540 equals 5x squared. Then we're going to divide both sides by 5. So x squared is equal to 108. and then we're going to square root 108. Add to three significant figures, that gives me 10.4. Just double check it doesn't ask for it in exact form. It doesn't, so 10.4 is fine. Part B asks for the angle between AG and the base ABCD. Let's draw the triangle that they're talking about. Here's AG, the base, so we want the line that's directly below that one running along the base. C is directly below G. There's that line. Let's complete that triangle. And let's make a copy of that triangle down here. And then we'll fill in any lengths that we've got. So we know that AG is 24. And hopefully we've got another length here. Yeah, we've got that CG is 6. And we want the angle between those. So let's call that angle there Y. And then we can straight away start using SOHCAHTOA. And we've got the opposite side and we've got the hypotenuse. So sine Y equals the opposite, 6, over the hypotenuse, 24. So Y is inverse sine of that. Put that into our calculator. And we get 14.5 degrees. This is a slightly tricky 3D Pythagoras question just because of the nature of this shape and because this steel rod doesn't go all the way to the corner this time, it stops in the middle. So before we start to do some calculation, excuse me, let's work out some useful measurements here. Now the whole way across here is 50. That means that halfway across on the top is 25 and halfway across on the bottom, well, the whole of the bottom is 36, so halfway across there is 18. I'm not sure if both of those are going to be necessary. Now, the corner of this rod goes from the bottom left corner, so it's going across 18, it's going up 40, okay, so across 18, up 40, and along 1.2 meters. So it's this 25 that isn't actually that useful. That's the one that we don't really need. Yeah, so you can see it's going across 18, along 1.2 meters and up 40. So those are the three measurements we're going to be using. Let's change that 1.2 meters into 120 centimeters. And do 3D Pythagoras with those measurements. So x squared equals 120 squared plus 18 squared plus 40 squared. 120 squared is 14,400. Plus 18 squared, 324, plus 40 squared, 1,600, I could have just square rooted them all as they were, to be honest. Never mind, I started this now. So it's a square root of 16,324, and that gives me 127.8, which to three significant figures is 128 centimeters. So a bit of a tricky one because we're not actually using the top there. That is because it doesn't start from the top, okay? It doesn't start from the top corner, otherwise we'd be having to use the distance from that top corner. It's starting from the bottom corner and going just to the middle there. So it's actually only going across half of the length of the base, so 18 centimeters. I think that's what makes that question a bit tricky. This question is a slight variation on previous ones because this time we're given some of the lengths, like we're given PV here is 17.2. And we're actually given the angle this time. We're told it's the angle between PV and the base TUVW. So let's draw the line that's straight underneath PV going along the base. So there's our triangle. And we're told that that angle there is 43 degrees. Let's redraw that triangle over here in 2 dimensions. So this is 17.2 and this here is 43 degrees. And we are trying to find PT, which is that side there. Now if we redraw that triangle like that, it actually becomes quite straightforward to see how to find PT. Let's label that side there X, and we can straight away go to using SOHCAHTOA. And we've got the hypotenuse and we've got the opposite sides. If we've got the hypotenuse and the opposite, that means we're using SOH. So sine X equals opposite, sorry, not sine X, sine 43 equals the opposite X over the hypotenuse 17.2. To find X, we need to multiply both sides by 17.2. So I get X equals 17.2 sine 43. And we're just going to plug that straight into our calculators. 17.2 sine 43. I get 11.3 centimetres. Sorry, not 11.3, 11.7 centimetres. That seems kind of reasonable considering that the diagonal is 17.2, so I'm happy with that. Another question where we've got a midpoint. So we're going to find the length of BM. First, let's write in some useful measurements. So if M is the midpoint of HG, well, HG is 14, so from M to G is 7. So this line goes across 7, back 5 and up 8. So it's almost like we're kind of making our own mini cuboid within this cuboid. Yeah, so if we kind of forgot about the rest of the shape and just imagine going along here, up here, yeah, and back that way. So the dimensions we're looking at are 5, that one there, 8 and 7, and once you've understood how that works, it becomes a straightforward 3D Pythagoras problem. Let's label this thing here X and do X squared equals 5 squared plus 8 squared plus 7 squared. So X is equal to the square root of all of those things. We could work them out, or we could just type that whole thing into our calculator if it's a calculator paper. I get square root of 138. I could leave it like that, or I can work it out to 3 significant figures. To 3 significant figures, that is 11.7 centimetres. Part B then asks for the angle that it makes with the base ABCD. Let's get rid of some of that messiness now. And let's draw in the triangle that we're going to use. So here's our line BM. Okay. Now, drawing this triangle is a bit trickier this time because directly below M is about here. Okay. I'm going to maybe call that point there X. Let's not use X, we've used that already. Let's use Z. So now I'm going to draw my line directly below. Directly below BM is the line BZ. And that's our right angle triangle that we're going to use. The right angle is there. I'm going to make a sketch of that triangle over here. There's the right angle. This is Z here. This is M here. This is B here. And let's fill in any lengths that we can. Well, we just found BM in the previous part of the question. Let's not use the rounded answer. Let's use the square root one. So square root 138. Do we know BZ? No, we don't. We do know ZM. That there is 8. Now, let's move that down here. We want the angle that BM makes with the base. That angle is this one here. Let's call it angle Y. On our little triangle, that's this one. And now we've got all of that information. Once again, we can use SOHCAHTOA. We've got the opposite and we've got the hypotenuse. So we're using SOH. So sine Y equals the opposite 8 over the hypotenuse root 138. So Y equals inverse sine of 8 over root 138. Put that into our calculator. I got 42.9 degrees. Job done.